Welcome to another video on our Blind 75 series. And this is the first Blind 75 problem out for, for the sliding window problem. In this window, is in this problem, basically, we're given an array of numbers, as you can see here, uh, called prices. Where prices, every element of that price array is the price of that particular currency on that particular day, right? So we need to basically choose a single day on which we buy the currency, and on a different day in the future in which we need to sell the currency, right? And we need to find these two buy and sell dates, which help us maximize the profit that we can achieve by sell operation. That's what this problem is about. So essentially, we have an index. We have an index of, let's say, the array we were given has numbers 10, 1, 5, 6, 7, 5, 6, 7, and then 1 again. This is the array we were given. Among this array, we need to find a date where we buy this and another date where we sell this. Yeah, and these two dates, when the selling price should maximize, these two dates should maximize value where selling price minus buying price. That's basically right. So we have one place we have a value called 10, as you can see graph here. Value called falls to value 1, 5, 6, 7, which the red arrows here representing fall in price and green arrows representing rise in price. So we need to buy the basic most simple principle. Remember for this problem is buy low and sell high. That's the most simple principle for any sell high. In this case, lowest price is 1 and highest price 10. There is something that we, even if we buy low and sell high, we can't go back in time because the x-axis is time. So we can't buy at this price of 1 and then move back to the 10 price and pay, sell it there basically. So because we can't move back in time, the only thing we can do on across this x-axis is to move to right, right? So to do that, we need to find the highest price after 1, which pays us a profit of, which after right of 1, we can sell this for the highest profit, and that seems to be 7 here, right? So our profit would be 7 minus 1. That is the answer to get from this. As you can see, that is also the problem with this first input array. And how do we go about it, right? We could have two pointers here, left pointer and the right pointer, right? Both pointers look at each other. Basically, we presume that the left pointer is the buying pointer. What we can do is one pointer as the buy pointer, B. We have a buy pointer, and then we have a sell pointer on the step next to it. So buying at 10 and selling at high, it gives us a loss of 9, right? And selling at 1 doesn't seem like an ideal place. So in that case, we'll cut this and sell at 5. At the same time, buying at 10 doesn't seem logical. So we cut this and we buy at 1. If 1 is the lowest problem. So we buy 1, sell at 5. We record, at the same time, we have a window that records our max profit. So in this case, uh, our max profit with buying 1 and selling at 5 is 4. Then our max profit, when we go when this pointer is cut, the selling pointer goes to 6. Uh, our buying price is 1 and selling price is 6, so our max profit increases to 5. Similarly, if we cut this and go to 7, our maximum profit uh, is 6, and that's the answer. But a computer doesn't know that, so it would cut this and go to 1, and the selling price is 1, whereas you so the buying price, maximum price, is 6. That's our answer. So now that we have that answer, and basically this is the logic that you need to use to solve this problem. Let's go back to the problems page here and start coding the problem out. So first, we need to initialize a min price as infinity and maximum price as before that rather. Let's revisit our approach to this problem. To initiate two variables, the minimum price and the maximum price. Minimum price tracks the minimum price encountered so far, starting with infinity, and infinity because anything less than infinity is automatically, is everything is less than infinity. So any number less that would come in forward would be tracked as minimum price. And max profit is set at the price of 0 because any number after that is max profit. So that is basically how we're going to create these two variables first. Then we iterate through the list, and for each day's price, we check if it's lower than the current minimum price, and if so, we update the minimum price to that price, and then we calculate the potential profit if we are to sell on that day, basically price minus minimum price. If this price is greater than the current max profit, we update max profit, and then we return the max profit after iterating through the list, the value of max profit will uphold the maximum profit as possible. So again, we started by bringing our pseudocode uh, here and pasting it here, and we need to initialize min profit as infinity and max profit as 0. Let me do that. Here, variables right now, 0. Have created these two variables. Uh, yeah, I think I've I've written infinity incorrectly. So infinity JavaScript is infinity. Python, it's floating under the floating point number. We just write inf basically. So that's infinity in Python, and I just wrote infinity in terms of JavaScript. Then we need to loop through each price. Basically, for that we need to create a for loop, but we write our pseudo first because that's so. What we write the next our for loop, which is that's our first one. We then bring on the sub pseudocode, which tells us what is the first decision-making thread that we need to look into. That is if the minimum price, update the minimum price if the current price is lower. So we that. So if price is less than minimum price equals to price. Write that down. Have that sorted out. Then we need to bring in the next pseudocode, which is to calculate the profit if we sell at the current price. And if this profit is greater than the existing profit, then we update that there. So down the profit is price minus rather minimum price. Then the next thing and the last thing on our pseudocode is to update the max profit. Calculated profit is greater than the current max profit. So if that is the case, greater than then, simply speaking, we make max profit equal to profit. And then we return. Run this code. This should supposedly solve this problem in both cases correctly, and that is what happened. With that, we can wrap up the first sliding windows problem in line 75 list up. And before I log off, if you got any utility out of this video, please like and subscribe on this channel, as well as please comment on our comment section and let us know if there's any coding interview problem that you solve as well. With that, I'm going to wrap this video up, and we'll see you in our next video. Thank you.